Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, students.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
wabarakatuh.
Morning.
How are you today?
I'm fine, Mister. Thank you.
Thank you.
Okay. Before we start the lesson, let's say pray together. Angelina, will you lead the prayer, please?
Yes, Mister. Let's begin to pray. Amin. Finish.
Okay, thank you, Angelina. Okay, let's check your attention, student. Who is not here yet?
Nothing.
Who
Nothing,
is?
Mister.
Okay, nothing, yes. Okay. Does anyone still remember last week learning about words?
The last in discussing about the nuclida.
Okay, yes, that's right, Siti. Our last discussion was about nuclida, isotope, isobar, and isoton. Did you remember isotope?
Yes, I remember, Mister.
Yes, Angelina.
Isotope is an element with the same number of proton or atomic number, different mass number.
Okay, good, Angelina. Give applause for Angelina. Okay, student. Today we are going to discussion about relative masses, atom, and molecule masses.
Yes, Mister.
Okay. Have all seen the PowerPoint, students?
Yes, Mister.
Yes, Mister.
Still a session about learning today.
Yes, Mister.
Must be an intention. Administration make your parents smile with your success. Okay.
Okay, Mister.
Okay. Let's send the PowerPoint. Learning objective. Number one, learner are able to calculate the relative atomic mass. And number two, learnings are able to calculate the relative molecular mass. Okay, today's topic. Angelina, what is the relative atomic mass?
Yes, Mister. Relative atomic mass, or AF, is the relative atomic mass is the mass of an atom determined by comparing it to the standard atomic mass. Relative atomic mass, abbreviated to AF, based on UPAC, used is a standard for determining the mass of relative atom is carbon atom. The atomic symbol is J.
Okay, good. Okay, good, Angelina. Thank you. Relative atomic mass is the mass of an atom determined by comparison it with the standard atom mass. Please your scene for point in video.
In the previous video, we have seen how atomic mass is measured. Now let's understand atomic mass in detail. Before that, can you tell me what exactly the concept of atomic number is? Can you define it once for me? Yes, it's simply the number of protons present inside the nucleus of an atom. Now, on similar lines, can you tell me what atomic mass could be? Yes, it simply means the mass of an atom. But how does it get determined? Imagine we have a bag which is made up of extremely thin material, so thin that it almost does not have any mass of its own. Now we fill this bag with some stuff inside. If this bag is placed on a weighing scale, then can we say that the total mass of the bag will be the sum of the mass of all the objects inside it? Absolutely. Similarly, the mass of an atom can be calculated with the help of the subatomic particles in it. But we know that among all the subatomic particles, electrons have negligible mass. That is, they are considered to be almost weightless. So what are we left with? Yes, we have both protons and neutrons in the nucleus. And these two do have some amount of mass, is what we know. Now tell me one thing, which among these two particles should be considered? Shall we consider only the mass of protons or only the neutrons or both together? Well, since both have a significant amount of mass, we will consider the mass of both together. Hence, the atomic mass is defined as the total number of protons and neutrons present inside the nucleus of the atom. It is also referred to as the mass number. Let us take a simple example. In case of a simple element like fluorine, we find that there are 9 protons and 10 neutrons in the nucleus. Second, we have always come across cases where the atomic nucleus has an equal number of protons and neutrons. So how is it that the number of neutrons is more? Well, tell me, does the presence of additional neutrons really bother the atom? Does the charge of the atom increase or decrease? Absolutely not. That's because they're neutral. Then why should an extra neutron bother us? So coming back to the atomic mass of fluorine, we have 9 protons and 10 neutrons. That means the total would give us 19. So can we say that the atomic mass of fluorine is 19 units? That's right. Just like fluorine, even aluminium has an extra neutron compared to the number of protons. That is, in a single atom of aluminium, we have 13 protons and 14 neutrons. Summing up the two, we get 27 units, which is the atomic mass of aluminium. Now let's take another random example of chlorine. A chlorine atom has 17 protons and 18 neutrons. That means the atomic mass of chlorine will be 35 units, right? Absolutely. But wait a second. A few chlorine atoms that exist in nature exhibit a different form. Some of them have 17 protons and 20 neutrons. That gives us the atomic mass of chlorine as 37 units. So which one is the correct atomic mass? In case of chlorine, both the atomic masses are right. The atoms having 17 protons and 18 neutrons have an atomic mass as 35 units. On the other hand, chlorine atoms with 17 protons and 20 neutrons have an atomic mass of 37 units. But now the next question to pop up in our minds is, how can we have one element having 2 different kinds of atoms? And is this valid only for chlorine, or are there other elements also which exhibit this phenomenon? Let's find out more about this mysterious concept of isotopes in the next video.
Okay, students. You listen the for video. Relative atomic mass. Satu massa atom karbon, 12. The above send the formula of determining the relative atomic mass is a comparison of the effect mass of an element with 1/12 mass of one atom, carbon 12. Relative atomic mass. Look at the picture besides 4 minutes. Okay, 4 minutes. Now, there are two isotopes of carbon in natural, namely the carbon 12 isotope and the carbon 13 isotope. Relative atomic problem example, since the foregoing, the mass of one atom of element X is while the mass of one atom of carbon 12. What is the relative atomic mass? Answer. Please send PowerPoint 4 minutes. Okay, next. Ya. Relative molecular mass. Okay, now Siti, what is the relative molecular mass?
Yes, Mister. Relative molecular mass is a comparison between the average mass of one molecule again. One or 12 the mass of one atom carbon 12.
Okay, good Siti. Thank you. Relative molecular mass is the ratio between the
Mister.
effect mass of one molecule to 1/12 of the mass of one carbon 12 atom. Please your send the picture in the PowerPoint. MR sama dengan sigma dari AR. Okay. Okay, all students, please read these 4 points. Reading in 10 minutes. Finish, student?
Yes, sir.
Okay. The relative atomic mass is the mass of atom determinant completing its the standard atomic mass. So, relative atomic mass affect to R based on UFIC international ions of for of late chemistry used as a standard for determining the mass of relative atomic mass. The carbon 12 atom is used for standard, so that units for atomic mass the defines as a mass of X3, same magnitude of as on whereas the mass of carbon 12 atom. Do you understand?
Yes,
Yes,
understand, sir.
understand. Yes.
Okay, good. There are that's relative molecular mass is a comparison between the effect mass of one molecule against 1/12 the mass of one atom carbon 12. In one molecule, a substance consists of its constituent atom. For example, one molecule CaOH, same mechanics or as one wells the mass to atom O and to atom H. You understand?
Understand,
Yes,
sir.
understand, Mister.
Okay.
Are
Okay. Please see the video relative atomic mass.
Now let's move on to something called the
Okay,
relative
mister.
molecular mass. Most of the time we are working with molecule.
Wait ya.
Now let's move on to something called the relative molecular mass. Most of the time we are working with molecules and compounds, so we have to learn how to add up all the relative atomic masses. So let's look at that now. The relative molecular mass is the average mass of one molecule compared to the mass of 1/12 of a carbon atom. So instead of the word atom, now we are looking at a molecule. But again, we are comparing everything to 1/12 of a carbon atom. The relative molecular mass has a symbol Mr, while the relative atomic mass has the symbol Ar. The relative molecular mass is taken by adding up all the Ar of the atoms in the molecule, and it doesn't have a unit. Let's take a look at some examples. For nitrogen, N2, there are 2 nitrogen atoms in the molecule. So when we calculate the Mr, we have to take 2 times 14, which is equal to 28. So 14 is the relative atomic mass of nitrogen. For hydrogen chloride, it will be 1 for hydrogen plus 35.5, giving us 36.5. In carbon dioxide, the relative atomic mass for carbon is 12. And we have 2 oxygen, so 2 times 16, which is 44. For ethanol, we have 2 carbon, 5 hydrogen, 1 oxygen, and 1 hydrogen. So you can see the working here. 2, 12, 5 times 1, 16 plus 1. So always show your working when you calculate the Mr because marks will be awarded. Now have a go at calculating the relative molecular mass of each of the following substances. Pause the video now. Here are the answers. You get all of them correct. Great, let's move on. I want to introduce one more term here, which is the relative formula mass. The relative molecular mass only applies to covalent substances because they exist as molecules. But when we talk about ionic compounds, we can't use the word molecules anymore. So we have to use what we call a formula unit. So the relative formula mass applies for ionic compounds only. But again, we compare this with carbon atom. The relative formula mass has the symbol Mr again, same thing. And we add up all the AR of the atoms in the compound. So whether it's molecular mass or formula mass, we use the symbol Mr, just that one refers to covalent. To covalent compounds, while the other refers to ionic compounds. Let me show you some examples. We have potassium hydroxide, that is 39 for potassium, 16 for oxygen, and 1 for hydrogen. We add them up, 56. Mg, 24. S, 32. 4 oxygen, 4 times 16, 120. Lead 2 nitrate, PbNO32. So 1 lead ion, 207. 2 nitrogen, and 6 oxygen. So when we have brackets like that, you must remember to multiply by the number that is outside. Okay. Okay, next example, iron 2 sulfate crystals. You would see this formula before when we learned the chapter on salts. So this is called the water of crystallization, and is added behind the formula of the ionic compound with a dot here. So what we need to do, this dot simply represents a plus. So we have to add 7 water molecules behind. So from the front, 56 for iron, 32 for sulfur, 4 oxygen, plus 7 water molecules. Okay, so 7 water molecules. And the answer is 278. So that's it. Okay, how to calculate the relative molecular and formula masses of different elements and compounds. Have a go at these questions. Pause the video now and try these examples. Did you get all of this correct? Great. That's the end of the video. Thank you.
Okay. I will again video this 4.27 minutes.
Now let's move on to something called the relative molecular mass. Most of the time we are working with molecules and compounds, so we have to learn how to add up all the relative atomic masses. So let's look at that now. The relative molecular mass is the average mass of one molecule compared to the mass of 1/12 of a carbon-12 atom. So instead of the word atom, now we are looking at the molecule. But again, we are comparing everything to 1/12 of a carbon-12 atom. The relative molecular mass has a symbol Mr, while the relative atomic mass has the symbol Ar. The relative molecular mass is taken by adding up all the Ar of the atoms in the molecule, and it doesn't have a unit. Let's take a look at some examples. For nitrogen, N2, there are 2 nitrogen atoms in the molecule. So when we calculate the Mr, we have to take 2 times 14, which is equal to 28. So 14 is the relative atomic mass of nitrogen. For hydrogen chloride, it will be 1 for hydrogen.
Okay, students, you understand? for the video relative molecular mass?
Yes, understand, sir.
Okay. Angelina, understand?
Understand, Mr.
Siti, understand?
Understand, Mister.
Okay, good student. Relative molecular mass, molecular atom. Example notes that's the relative atomic mass of carbon 12, hydrogen 1, and oxygen 16. Calculate average molecular masses of the CH3COH compound. Answer. Molecular mass CH3COH 2 RC plus 4 ARH plus atomic relative O. Okay. Reading is the 4 point problem example to relative molecular mass. 4 minutes. 4 minutes to reading for the problem example to relative molecular mass. Okay. Okay, students. Ready? Ready, students?
Yes, sir.
Okay. Do you any question?
Nothing.
Nothing, Mr.
Okay. Siti, any question, Siti? Okay. Okay. Now anyone can conclude today listen.
I am, sir.
Okay, please Ranti.
Okay, thank you. Relative atomic mass is the mass of an atom determined by comparing its with the standard atomic mass. Relative atomic mass abbreviated SIR.
Okay, good.
Okay, sir.
Thank you, Ranti. One more. One more. One more. Angelina.
Yes, Mister.
Now anyone concludes today lesson? Ranti?
Yes, sir.
Okay, anyone can conclude today lesson? One more.
Relative molecular mass is the ratio between the Bragg mass of one molecule to ones or 12 of the mass of one carbon 12 atom.
Okay, good. Thank you, Ranti. Please applause for Ranti.
Thank you, sir.
Okay. Today, material concrete is relative atomic mass is the mass of atom and determine comparing it with the standard atomic mass. Relative atomic mass breaks as ER. Relative molecular mass is the ratio between the average mass of one molecules to 1/12 of the mass of one carbon 12. Okay. For homework, you do the exercise. I will send exercise in group class. Calculate the next week.
Yes, Mister.
Yes, sir.
Thank you.
Thank you.
Okay, you are welcome. Okay, because our time is up, before we finish the lesson, let's say a prayer together. Angelina, will you let's prayer, please?
Yes, Mister.
Okay, Angelina.
Before we finish our lesson, let's begin to pray. Finish.
Okay, thank you, Angelina. Okay, I hope you enjoyed the lesson today. Assalamualaikum warahmatullahi wabarakatuh. Good morning, student.
Waalaikumsalam warahmatullahi wabarakatuh. Morning, Mister. Thank you, Mister.
Thank you.
Okay, thank you, student. Bye-bye.